Normalization is a process of organizing the data in the database to avoid redundancy, insertion anomaly, updation anomaly and deletion anomaly. Basically, we have 4 types of normalization. That is first normal form, second normal form, third normal form and Bayes code normal form. Whenever table follow 4 constraint, we can say that the particular table or the particular relation is in first normal form. Hello everyone, welcome to one more session on the database management system. Myself Induje, Faculty of Computer Science Department, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Today in this session we are dealing with normalization. What is normalization? Data normalization. In the previous session we have discussed what is anomaly, inconsistency, what is redundant data, everything. Now we are going to discuss normalization. Why we are using normalization? To reduce the redundancy in the database, we have to use the normalization. Let's have the definition for the normalization. Normalization is a process of organizing the data in the database to avoid redundancy, insertion anomaly, updation anomaly and deletion anomaly. This is a definition for normalization. What it is? Normalization is a process of organizing the data in the database to avoid redundancy, insertion anomaly, updation anomaly and deletion anomaly. Normalization is used to minimize the redundancy from a relation or a set of relations. It is also used to eliminate undesirable characteristic. Undesirable characteristics means which is not necessary, like insertion, updation and deletion anomalies. Normalization divides a large table into a smaller table and links them using the relation. What we have discussed in the concept of decomposition, that is what we are doing with the normalization also. Normal form is used to reduce the redundancy from the database table. So how many types of normalization, how many types of process we have to reduce the redundancy? Basically, we have 4 types of normalization. That is first normal form, second normal form, third normal form and Bayes code normal form. That is, we call it as 1F, that is first normal form, 2F second normal form, 3F third normal form and Bayes code normal form is called as BCNF. Let's see each type of normalization one by one. The first normal form, when we can say the relation or the table is in first normal form. For the table to be in the first normal form, it should follow 4 rules. Whenever table follow 4 constraint, we can say that the particular table or the particular relation is in first normal form. What are those 4 constraints? So it should have only the single valued attribute or the column. See, if this is my table, how many I have? Say 3 attributes, attribute 1, attribute 2 and attribute 3. Each attribute should have only one value, 0, 0, 1, A, B, C, X, Y, Z. Okay. If it is X, Y, Z and L, M, N, so it should not be like this. Okay. That is called as every column should have a atomic value. Every column should have a atomic value. This is a first constraint to say the table is in first normal form. What is the second constraint? The value stored in the column should be of the same domain. Same domain means if I have seen this is a number, it should be of the type number. If it is a name, the domain should be of the name. Here I cannot put 1, 2, 3. Okay, that is a representation of bad database. So it should not have any such type. It should have the same domain value. That is a second rule that we have to say the table is in a first normal form. Then the third rule what we have is all the columns in the table should have a unique name. All the columns in the table should have a unique name. This is employee ID. This is name. So here again I cannot have a employee ID. This is wrong. So all the columns, that is employee ID, name, job, department and skill, all should have a unique name. It should not repeat its name. Column name should not be repeated. That is a third constraint what we have. Then the fourth constraint, and the order in which data is stored does not matter. A table is in the first normal form. In which order you are storing the data, it does not matter. You can store the data in any order. You can do it in 1, 2, 3, 4 or 5, 6, 7 or 8, 7, 6 like that. The order does not matter here. What all the four constraints to be said? The data or the table is in the first normal form. First, it should have a atomic value for the each attribute. Second, it should not have more than one value in the each column. Third, all the column names should be different. Okay, these are all the main thing. If and only if all the column contains only the atomic value, that is each column can have only one value for each row in the table. That is what? Here we are satisfying the first normal constraint. Here also, here also, here also, and here also we are satisfying the first normal constraint. Here what we are doing? Here in the skills we have more than one values. That is C, Perl and Java. It is holding more than one value. So, how to make this type of table in the first normal form? Either we can divide the table, decompose the table as two tables. One is employee table with how many attributes? EID, name and job, and one more employee skill table where we have EID, DID, that is department ID, and then skill. Skill 1, skill 2, so on. We can divide. So this is how we are decomposing the table to get it into the first normal form. Next what we have is second normal form. What is a constraint to say the table or the relationship is in a second normal form? That is the first constraint, it should be in the first normal form. It should satisfy all the constraint of the first normal form. And the second point is that there should not be any partial dependencies. What do you mean by partial dependencies? Here we have employee code, project ID, employee name and project name. Here employee name is dependent on what? Employee code. That is complete dependency. Each employee having his code. And here project name does not depend on employee code. Okay. Here project name depends on what? Project ID. This is a partial dependency. All the attributes of the table is not dependent on the key attribute. Some of the attributes of the table is dependent on some other candidate key attribute. That is called as partial dependency. When we can say the table or the relation is in second normal form, it has to satisfy two constraints. One is it should be in the first normal form. Second is there should not be any partial dependencies. When we can say there is a partial dependency exists, we have some condition to say the partial dependency exists. That is left hand side of functional dependency must be subset of candidate key. and right hand side of functional dependency should be a non-prime attribute. So what is this candidate key and what is this prime attribute? There is a condition to check partial dependency. This is a functional dependency. A determines B, C and D. Okay, left hand side of the functional dependency must be a subset of candidate key. This should be what? Subset of, not the proper set. Subset of candidate key. Okay, and the right hand what we should have, that is a non-prime attribute. What you meant by non-prime attribute? The attribute that is not contributing to form the candidate key. What you meant by candidate key? Candidate key is any unique key in the table which is not the primary key. For example, in an employee table, employee ID is a primary key. Apart from employee ID, you can have the unique IDs for the employee, as its social security number, as employee's passport, as employee Aadhaar. These are all what we consider as unique value that each employee can have, and those type of unique keys are called as candidate key. Okay, then what is a prime attribute and non-prime attribute? The attribute that is participating in making the candidate key is called as prime attribute, and attribute that is not participating in making the candidate key is called as non-prime attribute. Okay, this is very important, how to find the partial dependency by checking the condition. LHS of the functional dependency must be the subset of candidate key. It should not be the candidate key. It should be the subset of the candidate key, and we are using the AND operation, very important, and right hand side of the functional dependency should be the non-prime attribute, means which is not participating in making the candidate key. By these two definitions, we can find whether there is a partial dependency in the table or not. If there is a partial dependency, then we can directly say the table is not in 2NF form. Next, the employee code and the project ID are the table's prime attribute in the above mentioned example, because employee code and may identify the employee name and project name can be determined by the project ID. It's saying we can determine the employee name by the employee ID and project name by the project ID, which is a partial dependent, which is not completely dependent. To overcome from that such constraint or such table, we have to go for again decomposing the table. So here you can see this is a base table. Right, base table. To make this table into 2NF, they are decomposing that into two different table, as an employee table and as an employee project table. Here employee name completely depend on the employee code, and employee project ID complete depend on the employee code. This is a primary key here. This is a primary key. These are all the attributes which is dependent on the primary key. Okay, this is about second normal form. Decompose the table such that it should fall under the constraint of the second normal form. Then we have as a third normal form. So employee code and the project code, they have divided as employee project table as well as a project detail table. By splitting the employee project detail database into the employee detail and then the project detail, we are making the table into the second normal form. Then what we have is third normal form. What you mean by third normal form? Again we have a two constraint to say the relationship is in a third normal form. The relation is in the third normal form. One is, that is, it should be in the second normal form, and it does not have any transitive dependency. We have already discussed what is transitive dependency. It should not have any transitive dependency, that A produces B, comma B produces C, and A determines C. This is a transitive dependency. It should not have any such transitive dependency. Here, in the same example, they have taken employee code, employee name, employee zip, and employee city. Okay, here employee zip depends on employee city. Always the zip code of any city depends on zip code. Any city name depends on the zip code. So let's see the example what they have seen. Here the employee code, employee city, transitive dependency prevents the table mentioned above from the being 3NF. Here in the previous, employee code and employee city have a transitive dependency. How it has a transitive dependency? Employee code determines employee city. Employee code determines employee city, and employee city determines zip code. If employee city determines zip code, that is employee ID determines city and city determines zip. Right. So in turn, employee ID determines zip. Right. This is a transitive property or transitive dependency what we have. If it is there, it should not be, the table is not in 3NF form. So what we are doing to make the table in 3NF, we can divide the employee detail table into the following two tables by eliminating a transitive dependency from it and normalizing it into the third normal form. The previous, we have 4 attributes. Here we are dividing that into different table. In first table, we are having employee code, employee name, and employee zip code. In the second table, employee location, we are having employee zip code and employee city. We are dividing or decomposing the complete table to make that in the third normal form. The condition to check whether there is a transitive dependency or not, the first is LHS must be candidate key or RHS must be a prime attribute. So by this condition, we can check whether there is a transitive dependency is there or not. If this condition is true, then there exists a transitive dependency. If this condition is false, then there is a no transitive dependency. Okay. By breaking the employee details, the data down into the employee details and employee location table, which the both are in 2NF and do not have any transitive dependencies. You can see here, we don't have employee code determines employee name determines employee zip code, and here employee zip code determines employee city. There is no transitive dependency. So we can say now the relation is in third NF, that is third normal form. Next, the 2NF and 3NF remove the redundant dependency on the candidate key and they set certain additional restrictions on them. They may, however, still have certain dependencies that result the database redundancy. Even if you are converting the table in the form of 2NF or in the form of 3NF, still some more redundant data will be there. To remove such redundant data, we pose more restriction on BCNF, that is bias code normal form. Here, they are saying that table R is in the bias code normal form if for every non-trivial functional dependencies. That is, ek determine A, X is a super key. That is, left hand side should be the super key, and at the right hand side of the functional dependency should be the prime attribute. Right hand side of the functional dependency should be what? Prime attribute. So then we can say that the relation is in a BCNF form. So what if it is not BCNF form? Again divide or compose the table, then you will get the table in the BCNF form. Let us use the following employee project lead table as an example. We are taking one example to convert from one NF to the BCNF. Here how many attributes we are having? Employee code, employee ID and project lead. In this, the preceding table satisfy all the conventional forms of 3NF. Still 3NF, it is correct. It satisfy all the constraint of third normal form. Since it is a candidate key is a employee code and project ID defines BCNF criteria. The project leader is a non-prime property of a non-trivial function. So what we are doing? Project ID is a prime attribute in BCNF. This is not the permitted. So project ID is a prime attribute which is not permitted. Then to make that table in BCNF, again decompose the table. Decompose the table. We divide the given table into 2 and translate them into BCNF. Employee project lead project table, we are having an employee code and employee working on which project, and in the second table what we are having project ID and project lead. Okay, which is project led by which of the employee. So here we are dividing that as an employee project lead and employee detail, 2 tables to make it in the BCNF form. So this all for the session. Thank you.